Interesting that she went to you. She okay? Okay. Yeah. Okay. So what's the plan? Okay. Which they won't.
Yeah. So she.
Okay.
So I think the office called us.
Pause. Here we go. Here they are. Some of you already marked it. I'm so happy for you. That's great. Still pay attention anyway. Is there anything anyone wants me to go over here? Once, twice, thrice. Well, I mean, I'll give you a second to look at all the numbers, but these are questions 1 to 12. Was that a hand? Nope, never mind. I thought you put your hand up. Okay. I'll slide this down. Here's the bottom ones. 9, 600, 472. Compare what you got with what I got. I once went through a class. It was 6 immediately. It was what? Okay. Going once. Twice. Is there anyone who'd be deeply offended if I flip the page? Sold. Okay. There's 17 to 26. The answers in order are 10, 26, 2, 4. You could leave it as 25 over 2 or write it as the decimal 12 and a half. 4, 0, 2, 0, and undefined. Are there any questions there anyone wants me to talk through? I wanted you to have them done. Don't just write down the answers if you haven't done it yet. I want you to actually go through and do it. You need to be able to show me your work. Because I am recording my video, and if you do want to go back and check your answers because you didn't get it done, don't write the answers down, but go back and check the beginning of today's video. The answers will be there. We do all remember how to access my YouTube page? Okay, cool. Here's the bottom 4, 0, 6, negative 30, and 2. Comments, questions, concerns on any of that? Going once, twice, thrice. Fantastic band. Sold! Too few who know who Thrice is. Okay. It's also a band. So many times, lots of what I say is a reference to something else. Band names I will emphasize, lines from movies and TV shows. I have been dropping quotes all semester already, and if you have picked up on it, it's been this subtle nod, but most of you haven't except for Miss Crusoe.
When did you go listen to Kanye?
When did I see Kanye? Fall 2005. November, specifically November 2005. I have no idea. He was the opening act. So Kanye wasn't big yet. He opened for U2. U2 was the band I paid to see, and Kanye was the opening act. So this was early in... He was the pre-show. This is before Kanye became Kanye, and then Kanye went crazy. Before all of that. This is when Kanye was still little. And the ego hadn't destroyed him yet. Okay, the last two here they are. 0, 2, 1, and 1. Yeah, man. They were there for so long. Oh, you're paying attention to my story about Kanye? There's the top. The last two, 39 and 40, are both 1. So I guess I don't need to show you that. Here's 31 to 38. Does anyone want me to go over any of these questions? I will happily demonstrate them. Going once. Slowly once. Done. Okay, cool. So those are the answers. Here's the bottom ones again. I told you both the answers are 1. Any of the ones I filled in are ones that past semesters have asked me to demonstrate, so I'm happy to do more of that if you'd like. Otherwise, and this is how I want you to show me your work. Changing 1 or 2 things at a time, writing things directly below. Like, when I look at your pages, every box should look like this. Right below the question, I've changed 1 or 2 things at a time. If this is not how you're doing the things, I'm going to give you grief. Next week when you do your first quiz and I don't see the work this way, I'm going to give you a hard time. Also, I will take off marks, which is a bigger deal to some of you. Some of you, the hard time is the bigger deal because you're like, I can't embarrass. I'm so embarrassed in front of my teacher. And some of you are like, screw that guy. But then I start taking off marks and you're like, oh, okay, I'll pay attention now. Okay, so fractions, let's do it. Oh, I have so many booklets in front of me here. Here we go. This one is you. Fractions review. I expect everything we do today to be review. If it's not, if it happens to be brand new, that's okay, but please come see me. Because that means there are things that you need to get caught up on. So, review of fractions. There's a pizza. This is how fractions get taught at the beginning. How many slices are there? 6. How many slices are in the whole pizza? 6. There's nothing missing. So one way to talk about this is to say, looking at that pizza, I could write it as the whole number. How much pizza is there?
1.
One whole pizza. But if you wanted to be that guy, because, sometimes it's fun to be the mathy, annoying person at parties, you could talk about that one whole pizza as being made up of fractions of the whole. If you did that, this one whole pizza would be what equivalent fraction?
4, 6. No, 5, 6.
The whole pizza.
Whole pizza.
How many slices were there?
6, 6.
And there were 6 to start. So you could talk about it being 6/6 of a pizza or one whole pizza. This next one. It's the same pizza, like someone ate a slice. How many slices are remaining?
5.
How many were there to start? Does it look like? Assuming they were all the same size, there was 6. So what fraction of the pizza... Oh, no. Answer the question. How many were taken? 1 was taken.
1, 6.
So what fraction was taken?
1, 6.
1 of the 6th. How many are left? 5/6 of the pizza. You got to be clear what question you're asking. 1/6 of the pizza was taken because 1 slice was taken, or from the 6 that were there. Or how many were remaining? Well, 5 were remaining of the 6 that was there. So what fraction of the pizza is still there? 5/6. This is what fractions are for. Now we take them and we do other stuff with them. If there are 2 people sharing pizza equally, how many equal slices did each person get? Assuming that it's this same pizza here.
3.
How'd you do it? 6.
I divided by 2.
You bet. How many slices did each person get?
3.
We said that already. 3. So what fraction of the pizza do they have?
1 half.
Or
3/6.
3/6. They have 3/6 of the pizza, but we did already establish that if 2 people are going to take it, this is equivalent to half the pizza. And again, so often we don't think about things this way, but that's really all fractions are. And if we all spent a little bit more time thinking about things from this angle, fractions wouldn't be quite so scary. For those of you who are scared of things, you should scared of fractions, you should take up baking. Okay, fractions have 2 parts. What do we call the parts of a fraction? A numerator is the top part. It is what portion was taken or what portion remains. It is usually, it is the lesser of the whole. And the bottom number is called the denominator. And it is the total number of equal parts in the whole. There are different ways to represent fractions. You can write fractions as proper, improper, or mixed. What is one of those 3, Dea? Give me one of them.
Improper fraction when the numerator is bigger than the denominator.
So let's write that definition in here. The numerator is larger than the denominator. So Dea, I would like you to give me an example of this using an odd numerator and an even denominator.
15/8.
Sure. There's a fantastic example of an improper fraction. Someone else. What is one of the other two? Bosco.
Mixed is when you have
Mm.
whole number and a fraction.
Mixed is when you have a whole number. That's not a hashtag. That's a number sign. I just don't want to write out the word. A whole number and what kind of fraction, Bosco?
Proper.
A proper fraction. So Bosco, I'd like you to give me an example of a mixed fraction. We also call mixed fractions mixed numbers. They mean the same thing. Give me an example of a mixed fraction or a mixed number.
5 and 3/4.
5 and how many fourths?
3.
5 and 3/4. Love it. So then we used something we haven't talked about yet to define what a mixed fraction is. So based on what Bosco just gave us, what is a proper fraction if 3/4 is a proper fraction? Dea.
It's a number where the numerator is bigger than the denominator.
You want to give that a one more shot?
Oh. It's also a decimal.
Nope. It's a fraction. Define it. We're going to give Dea one more chance to get it right.
Can I get a call friend?
You got to call one of those two guys.
I call for Sean.
It's where the denominator is larger.
The denominator is larger than the numerator. There it is. Denominator is larger than the numerator. Love it. When you're ready, flip the page. So we've got the types of fractions. Now we have to talk about simplifying them. What does it mean to simplify a fraction?
Make it as small as possible.
So Bosco says here smallest possible fraction. Possible. I guess spell possible, right? Another way to think about it is reducing the fraction. Dea, what's another way to in lowest terms? All of this language is the same. If I want the smallest possible fraction or the lowest terms fraction or the fraction reduced or the fraction simplified, you need to recognize that all four of those instructions mean exactly the same thing. So, I have a pizza. It's a whole pizza. I take the pizza, and now I only have half the pizza. What is one way to represent how much pizza I have right here?
1 second or 1/2.
One way I can think about it is I have half the pizza. But how many slices did I start with? And how many do I have now?
3.
So I could talk about this as having 3 of the 6 slices, but if I want to talk about that fraction in smallest possible terms, lowest, reduced, whatever, we would talk about that as being those 3 of 6 slices. We would talk about it as being half the pizza. And so there's a method to this. How do we get from this 3/6 down to a half?
Divide by 2. No, by 3.
If we divide both 3 and 6 by 3, 3 divided by 3 is 1. 6 divided by 3 is 2. I'm doing math absolutely backwards there, and that's an atrocious way to write it, but that's what we've got going on now. So there's 2 methods for this. depending on the size of the numbers involved. Here's your first method. Okay, to simplify your fractions, to write them small as possible, I've got two methods in the same example here for both of them. The fraction we want to reduce is 6/54ths. I don't know why you cut a pizza into 54 slices, but you decided that that was what you were going to do, and then now you've only got 6 of them left. So, what fraction of the pizza do you have left? The first method, Dea, you're reducing it. How are you doing it?
I know the division method.
Okay, well, they're both dividing methods. Okay, you know what? Let me talk and then put your hand up afterwards. So, the first method is I'm going to look at this thing and I want to find any prime number that will divide out 6 and 54. If you recall, a prime number is a number that does what? Or what is the definition of a prime number?
That it can only be divided by 1 and the same number.
So prime numbers are divisible by 1 and itself. If you can find prime numbers that will divide out of your fraction, you can make your life real easy. So the smallest, well, the first 9 prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19. There are infinitely many of these things, but let's pick one. What is a prime number that will divide out of 6 and 54? 3 works. What if you don't know that 54 is divisible by 3? Because it's not necessarily obvious to everyone that that's true. 2. How do you know that 54 is divisible by 2?
Because if you divide it in 2.
No, don't tell me what you'd get. Just tell me how you know you can. These are both even. Even numbers 2, 4, 6, 0, 2, 4, 6, and 8. If any number ends in the last digit 0, 2, 4, 6, 8, divisible by 2. So you don't have to find the elegant solution. You can just say, oh, look, it's divisible by 2. Start dividing. 6 divided by 2, 54 divided by 2. 6 divided by 2, it's not bad. 6 divided by 2 is 3. 54 divided by 2 is a little trickier. You could say an easy way to do this, easy if they get easy. The simplest way to do it in your head, if you're struggling with what 54 is divisible by, even though you know it's divisible by 2, is to look at 50. What's half of 50? 25. And you should know this because of money. 50 cents is 2 quarters. So 50 divided by 2 is 25. So then 4 divided by 2 is 2. So then 54 divided by 2 is going to be 2 more than 25. It's 27. Unfortunately, that one does not show up on your multiplication table because we only go up to 20s. But if we relax the restriction on primes a little bit, can you find 54 on here? 54 shows up a bunch of places. 54 shows up there. 54 shows up there. Where else does 54 show up? Anywhere else?
Yeah, on the 19, the fourth spot, third spot.
That's 57.
And then, 18.
18. And then way down here. Those aren't prime, but let's come back to that. Let's bookmark that, shall we? So I've got 3. If I recognize both of these are even and I divide both of them by 2, I get 3 over 27. Am I done? Are we in lowest terms? You have to make sure that if there's no other number you can check. Fortunately, 3 and 27 are both divisible by 3. So 3 divided by 3 is 1. 27 divided by 3 is 9. As soon as you've got a 1 in the numerator, you're automatically in lowest terms. Okay. Let's take a gander there at that multiplication table, though. Another way to do this is not by primes, it's by common factors. Now, you can find, it does not have to be the greatest common factor. You just want to find any common factor. If you can find the greatest, awesome. Bonus. But it doesn't have to be the greatest. You just want to find a common factor. So, what are all of the things that multiply to give you 6? If you don't know, take a look at the sheet. Yeah, it shows up a bunch of places. It shows up in the 2 row, the 3 row, the 1 row, the 6 row. So 6 is divisible by 1, 2, 3, and 6. I've already circled this, so let's go back and take a look again. What is 54 divisible by?
6.
It's divisible by 6 and 9. It's divisible by 18 and 3. Let's write these down. 6 and 9. 3 and 18. Obviously, 1 and 54.
Also divisible by 2.
We did see that before, that it was divisible by 2. And 27. But let's look for something bigger than 2. What is a larger common factor we could divide 6 and 54 by?
6.
6. Shows up in both those lists. So, let's do it. 6 divided by 6, 54 divided by 6. When you're writing it out, write it out like this. You're dividing both the numerator and the denominator. 6 divided by 6 is
1.
1. And then if the mental math game is evading you, 54 divided by 6 is 9. The result is the same. As it should be. Questions, comments, concerns about reduction. From here on, you must reduce. Fractions should always be given in lowest terms. Flip the page. I want you to crank out this page. For question 1, I want you to do 2 things. If you've done these already, that's great. Go back and make sure you're actually answering what I want you to do. I want you to do question 1, representing the statements as fractions as the statement is written, and I want you to give me that same statement reduced. For example, the first one says Gurman baked 12 cookies. He ate 4 of them. What fraction of cookies did he eat? The statement as it's stated, what should the fraction be? Yeah, he ate 4 of them and there were 12. Is that thing reduced? No, because I can divide them both by. I could divide them both by 2. I could also divide them both by 4. I'm seeing lots of hands. I saw some 3s. Don't worry, I made that mistake earlier. 4 is divisible by 4, it's 1. 12 divided by 4 is 3. So he ate 4/12 of the cookies. That is equivalently him eating 1/3 of what was there. Somehow that makes it sound worse. He ate 1/3 of the cookies. What a monster. Okay, finish the page. You have 9 minutes if you're not done already. Go.
Wait, just the page?
Just the page. If you are done already, that's great. Done. Yeah, finish them. Some of you have not read ahead, and that's totally fine. I have no expectation you work ahead. Did you go last night? Wednesday. He's making you wait till Wednesday. Like you have an appointment with him? Don't flip ahead yet, because I am going to throw the answers up on the screen here in a second. When you are done. Should you reduce the ones number 1 as well? Good. 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 Oops. Are 3 questions that I'm going to get these guys done today. You've already done that I'm going to change. So when I do that, make sure you go back just to those 3. Not from this chunk, but from excellent. Sorry, the best in believe. Shameless. Now who? Oh, I've not heard of them. Where are they from? Okay. They just showed up and stopped us. There you go. 5 minutes. Those of you who aren't done. Crank them up. Yep.
Do you know what's it does?
I don't even know who that would be. None of us. No, it's not him either. Hmm. Come on. I want to see. Come on.
sign up that I got isn't working. So, it's up to you.
Seriously? What do you mean? How do you know it's not working? Like just with the password that you, or does it not exist, or you just?
I don't know. Every single one I gave them.
Yeah.
Every single standard.
Neither of them work. Lovely. Okay, here we go. German baked 12 cookies. He ate 4 of them. The fraction is 4/5. We reduced that to a third. B. What fraction of the pencils are marked number 3? If you reduce it, it's a fourth. Unreduced? 6 of the pencils of the 24, which we reduced to a quarter. Okay, C. What fraction of the roses are red? Unreduced and then reduced. Unreduced? 9/15, which we reduced to 3/5. These guys down here look like this. 2/6 is 1/3. 5/20, 1/4. 4/6, 2/3. 9/27, 1/3. 8/32, 1/4. 16/48. How'd you do that one, Dea?
I did 16 divided by 2, 48 divided by 2. I got 8 over 24. Then I did 8 over 20. I did 8 divided by 8 and 24 divided by 8.
Nice. Love that. 11 33rds is a third, both divisible by 11. 14/54. I saw a bunch of people hung up on this one because you were looking for some big, elegant solution. There isn't one. You have to divide both these by what, Dea?
I got 7 over 20.
It is 7 over 27 because you have to divide them both by 2. I saw a bunch of people stuck looking for a bigger value to divide by. Sometimes it doesn't exist. Divide them both by a number. They're both even, divided by 2. 100 over 55 is what as a fraction?
20 over 11.
20 over 11, which we could also write as a different kind of number. Are there any questions? We're going to write it as mixed here in a second. Are there any questions about any of those? Okay, on your mark and set, flip the page. Let's take a look at converting between mixed and improper. So just like that last question I gave you, that was an improper fraction. The result was 20/11ths. What does that even mean? If we're thinking about those in practical terms, 20/11ths doesn't make an abundance of sense. We'll introduce this again. This hopefully should be review. We'll introduce it by looking at equivalent ways to write the same amount of stuff. How much pizza do I have on the first column there? I got 1 pizza. In the middle, how much pizza do I have? I still have 1 pizza, but now I've cut it into 2 slices. So another way to represent the whole pizza is to write it as I have 2 halves. Equivalently, the whole pizza, if I cut it up into 4 slices, could be given as what? 4/4. These are all equivalent representations. And so what we want to do is we want to use this idea of equivalent representation to start looking at, well, how do I go about taking these improper fractions and making them mixed numbers? What's an equivalent way I could write it using wholes? So if I have 1 whole pizza and another half of a pizza, what's one way I could write that? How could I write how much pizza I have right here?
1.5.
I could write it as I have 1 whole pizza and I have 1/2 of a pizza.
Or 1.5.
Or if you, we're going to stay away from the decimals for now. What if I take this pizza and I lop it in half? How many halves do I have now? 3. I have 3 halves. And so some way there must be a method to jump back and forth between these equivalencies. They're the same, so there's got to be a way to do it. There is, fortunately. So rather than doing these two, we just did what these two are saying. Let's flip the page and look at the method. This is where, if you worked ahead, come back. Those of you who are marching ahead, come back to this page. We want to look at converting mixed fractions to improper fractions. What is the method?
Denominator by the number plus
Denominator by the
number,
whole number
whole number plus the denominator.
plus the numerator. So we're going to take the denominator. We want to multiply it by the whole number. And you want to add it to the numerator. So then 2.5 is the same as
5.
2 times 2 is 4 plus 1 is 5 over 2. And I mean, I can show you why, for those of you who want to see it. It looks like this. I have 2 wholes and I have a half. If I chopped this pizza and this pizza in half, how many halves do I have now? 1, 2, 3, 4, 5. So nice and easy. Let's do the next one. What is 3 3/5 as an improper fraction? 18 over 5. 5 times 3, I multiply here. 5 times 3 is 15. Plus 3 is, that's 15. Plus 3 is 18. And the denominator stays the same. Let's do one more example that's not written on the page. An example of a situation that I see students applying the rule without thinking about what's going on, and then they get screwed up. Here's the question. What if I take that and I make it negative? I have negative 2 3/5. Now, as far as like actual objects go, this doesn't make sense. How do we talk about negative 2 3/5 of a pizza? What's a negative pizza? It's not upside down or inside out. It's like, you could think about it being as owed. I owe you 2 3/5 of a pizza. How do we write this improperly, properly?
Minus 13/5.
You're suggesting it's minus 13/5. How'd you do it? You're correct, but give me the method, Bosco.
You transform it to one improper fraction and you just pass negative.
You transfer, for those of you who didn't hear what Bosco said, here's what you need to make sure you do. When you're converting this thing to an improper fraction, ignore the minus sign, is what Bosco said to start. 5 times 2 is 10, plus 3 is 13. And so you should get 5 times 2 plus 3 is 13/5. And because this is a negative amount of pizza, make it a negative amount of pizza. What do you think is the mistake I see time and time again that made me give you this example?
They multiply.
Sam, I saw that hand. What's the mistake? Yes, that is exactly the mistake we're trying to avoid. Do not do what I'm about to write down. What I see students do all the time is they say, okay, 5 times negative 2 is negative 10. Then they just blindly add the 3. What's negative 10 plus 3? Negative 7. And so at the end of the day, they'll be like, yes, 5 times negative 2 equals negative 10 plus the 3 is negative 7. And so they make this thing negative 7 over 5. But if you think about what we're going to do in a second here, what I'm going to get you to do in a second is go from improper back to mixed. If you think about that procedure, this obviously doesn't make any sense because 7/5 is less than 2, but I started with more than 2. So when you're converting mixed to improper, you want to make sure you do what Bosco has suggested, and what lots of people are going to do anyway. Ignore the minus sign, do the conversion, treat it like this. as if there was a giant set of brackets around the fraction that does not contain the minus sign. Do the conversion and then apply the negative sign after. This is bad. Down here, don't do that. Okay, so I want you to crank out these 9. Do the conversion from mixed to improper. I want these bottom 3 to be negative. G, H, and I want you to do those 3 as if those fractions were negative. Or those mixed numbers, rather, were negative. Crank them out. You got 5 minutes. If you already finished them, I want you to go back and make sure that G, H, and I are converting your negative. I mean, which if you do them properly isn't going to be a big change, but make sure you go back and make that change. Yeah, just make sure you do that. Just give me a sec. Because you're probably going to end up doing more work than I'm going to assign, but you know, if you get it done anyway, I guess it doesn't really matter. Okay. Crank out these 9.
Let's write down things right now. Take my notes.
there's negative one.
Okay, let's take a look at these things. If you're on your phone, put your phone away, bring it back. If you're on a different page, bring it back to this page. Again, review the method. It's you always want to start at the denominator, multiply the denominator by the whole, and then add. So the first one, 3 times 1 is 3 plus 2 is 5. And the denominator stays the same. You have 5/3. 4.5 is going to be? Dea, I saw that hand. 9/2. Because 2 times 4 is 8 plus 1 is 9. Denominator stays the same. Letter C, what is it? William.
23/6.
It is, in fact, 23/6. 6 times 3 is 18. 18 plus 5 is 23. Denominator stays the same. Next one. Love it. 23/11. Next one. Dea. 16/3. Love it. Next one. Dea, no. Let's go over here. 7/3. 3 times 2 is 6. Plus 1 is 7. Denominator stays the same. Okay, so then these ones, I wanted you to make them negative, but it really doesn't change how you go about doing them. Your final answer is just going to end up being negative. William, what is this one? Negative 31/10. 10 times 3 plus 1, and then make it negative. So then H is going to be?
28/13.
Negative 28/13, because I changed the question. But yes! And Dea, last one, your hands in the air.
Last one is negative 38/7.
Good. Cool. Questions, comments, concerns so far? Let's keep going then. Flip the page. The last little bit is the other way. Now, I hate the instructions for this one, but it's a really because it's such a wordy way to write it, but there's really no other good way to explain it. At least, I mean, if there is, I didn't come up with it. So let's take a look at what we've got here. We want to multiply the denominator by the whole number until you get as close to the numerator without going over. Again, that's a lot of language. That's wordy. So let's go ahead and actually do it. What are we going to multiply 2 by to get to 11 without actually going over 11? We're going to multiply by 5 because 2 times 5 is 10. So another way to think about it is I can take 5 groups of 2 out of 11. So that's going to become our whole. 5 is the number that, 5 wholes is what we're going to have as we pull groups of 2 out of 11. And then how much is left over? Well, 2 times 5 is 10 halves. But I have 11 halves. So the numerator would be 1. If we take out 5 wholes, we've taken out 10 halves. 11 minus 10 is 1, and the denominator stays the same. So this is the one where, I mean, the method isn't hard when you see it a few times. There is a little bit more mental math involved, absolutely. But at the end of the day, the procedure is easier than what it looks like when you write it out. We multiplied the denominator by a whole number to get close to the numerator without going over. That number was 5. The 5 then became our whole number. We subtracted the numerator using, or subtracted from the numerator using the answer from the multiplication. So the 2 times 5 was 10. We took away 10 from 11, got 1. Denominator stays the same. So we'll do 2 more, and then I will free you to play. 15 over 3. Some of you are going to see this and you're like, that goes in nicely. That's great. Humor me. Let's write it as a mixed number, and then we'll recognize. I know it's weird to think about doing that. What do I multiply 3 by to get up to 15? 5. And if we apply the method here, 3 times 5 is 15. If I subtract the 15 from 15, I'm going to get nothing, 0. So, I know, it looks weird, right? But, I mean, that's the method. What does it mean to have no thirds? It just means I had 5 holes, and that's it. Because 3 goes into 15 cleanly. The procedure works. It's unnecessary, but it works. So let's look at one that isn't quite so clean. I got this guy here. How many groups of 5 am I going to take out of 14? Or how many times can I multiply 5 by to get up to 14 without going over? Twice. So I'm going to have 2 holes there. Why is this 2?
But that's the whole number.
Well, yeah. Why is it the whole number? Because
multiply by 3 would be 15, and that's over 14.
Because if I multiplied 5 by 3, it would be 15, and we don't have 15, we only have 14. So 5 times 2 is 10. I've taken out 10 of the fifths. So how much do I have left? 14 minus 10 is?
4.
14 minus 10 is 4. And the denominator stays the same. So this is going to be 14 fifths becomes 2 holes and 4 fifths. The instructions are kind of complicated, and this one's definitely relies on more mental math. But again, nothing beyond what I believe all of you are totally capable of. Okay. So, wow, you guys have way more time than the first block did. I don't know if you just listened faster somehow or what, but you've got way more time than they did. Here we go. Oh, no, I know totally how that happened. Here we go. So, 2 and 4 fifths, you're done, we're good. Here's what I want you to do for homework. I would like you to crank out these 6. Flip the page. Those of you who haven't already rushed ahead and done it all, what I want to assign out of these first 9 are aces. What aces are is every other letter starting with A, or another way to think about it is odd letters. A, C, E, G, I is aces. In number 2, I don't want you to do all of number 2 either. I'm going to assign unto you BDFs.
That's even.
Even letters. B, D, F, and H. Flip the page again. Question 3, I want you to do aces again. So A, C, E, G, I, and it says H, but that's a typo. That should be letter K down there in the bottom row. Because it doesn't go H-I or... Wow, there's G-H-I again. Don't do that. I want you to... This one. G-H-I, that should be a J. K and an L. Whoops, my bad. Okay, and then I would also like you to look at this one. What is the difference between a 16-ounce brick and a carpenter? This one is also part of what I'm going to get you to do because you guys got loads of time. If you haven't done it already, this one I am going to make optional. You do not have to do this one. Why did the football coach send in a bunch of second-string players? If you did do that one, great. I want to know what your answer is. But if you didn't do that one, it's optional. So there you go. That is what I want you to play with. You have about 15 minutes to the bell, and then obviously you have a weekend ahead of you. May the force be with you. Good luck.